Good morning. We're at our wastewater plant here. My assistant is there at the slip ring. We're fault finding an earth fault on this secondary settling tank, Mitchell's Plain wastewater. Here's my megger. I've got it on 500 volts. Megger. There's the junction box. We're loosening. So this is my motor cable and this is my control cables. And this is the junction box where they all meet. So the two at the bottom is coming directly underground to the control MCC, and this multi-core over here goes from this box down under the tank, right under the water in concrete in a sleeve up until there where she is in the slip ring. So we are disconnecting. We disconnected from the MCC and we disconnected at the junction box. So now we're disconnecting at the slip ring, and we've disconnected at the motor and the other controls on the other side. So we have gotten from the earth conductor here, as you can see, there's a little metal fill here. So this is my test lead. I've got my positive test lead on there on the earth conductor, as you can see, and I've got my blue phase, my red phase, and my white phase, which is numbered 1, 2, and 3. Right, you see, there's number 1, there's number 2, there's number 3. So this is the motor cables. These cables goes through, this is connected to this multi-core. You can see I've cut the fiddles. And then of course it goes to the slip ring, which is 11 ring slip ring. From there's two cables. One is the motor cable, one is the control cable. So as this bridge rotates, it rotates around the slip ring, of course causing conductivity through the slip ring brushes to the terminals on the slip ring, on the brush terminals, onto the cables, and of course it goes down that way from the center to the left, where the motor is situated and the controls is situated. Controls will consist of your start button, your emergency start button, and of course a limit switch, which will suffice as an over torque cutout safety switch to prevent catastrophic happenings on these things, because these bridges, they've got enormous pulling power. That gearbox is very, very, very strong. So now we've gotten between the earth conductor and our blue phase. Now we know that if you test your insulation resistance, you should get infinity. Alright, between conductors you should not get any reading, or if you do get a reading, it should be a high reading, a high mega ohm reading, and not an ohm reading only. It should be mega ohms, meaning the resistance is very good between white, red, blue, and of course your earth. There should not be any conductivity between them. There should be no continuity, no nothing between them. It should be infinity. It's like that should not know about each other. Nonetheless, we've gotten on the blue less than 0.5 mega ohm. It was 0.43, I think, mega ohm. Of course this one was 1.2, this one was 1.6 mega ohm, which is really not a very good reading we want to get. We want to get infinity. Alright, so which means we had enormous nuisance stripping on this bridge, switches off the whole panel, and it was because of these cables. Of course it was faulty. It's from here. I'm not sure if there's a joint in between here and the MCC, might be, but there's cable damage underground. So these cables has to be replaced, and from here to the slip ring we've disconnected. We're gonna give you another video to show you if there is a fault from here to the slip ring. Thank you.